Hello everyone, welcome to Inspired Mechanical. In this video we are going to cover a problem of section of solid. See how the problem is being given as. A square pyramid is there. Read the statement very carefully. A square pyramid is there and you already know how the square pyramid will look like. It is containing a, you can say, square in the base and height is equal to 65 mm as given in the problem, and base side is equal to 40 mm. All the sides are 40 mm because it's a square, and height of the pyramid is 65 mm, or you can say axis height is 65 mm. Has its base on the HP. Okay, has its base on the HP in such a way that all of the edges of the base are equally inclined to VP. And what is the meaning of equally inclined? Equally inclined means in the top view our pyramid is equally inclined, which means that all sides are inclined at 45 degree to VP, and in the top view we can see that thing. This is my reference line xy. With respect to that we draw all the problems. So this plane is xy line and this is the top view. Okay, top view of our square pyramid, and that is inclined at 45 degree to this xy line. Okay, all the side, in fact this side is also inclined, this side is also inclined, so all four sides are equally inclined to our VP. That means 45 degree angle. Now it is cut by a section plane. Okay, square pyramid has been cut by a section plane. That section plane is perpendicular to the VP and inclined at 45 degree to HP. What is the meaning of inclined at 45 degree to HP and perpendicular to the VP? So in the front our square pyramid will look like this. This is a rough diagram. The fair diagram I will show you in the animation also just after that. So this is the axis. This is our pyramid axis. So the cutting plane is perpendicular to the VP, means our cutting plane is as a line in the front view, but in the top view we can see our solid as a sectional view. Okay, so in the front view it will look like as a straight line, and also it is bisecting the axis also, right? Bisecting the axis means this point is the middle of the axis. This point is middle of the axis, so this point is 32.5. Okay, and this angle is how much? 45 degree, or you can say here also 45 degree, right? So we need to draw its sectional top view and true shape of the section. I hope the problem is clear to you, how the problem is being given and how you need to draw. Let me show you. So initially what you need to do, draw in reference line xy. Draw in reference line xy, and we need to start with top view. Why? Because in the projection of solid I have also discussed that the view in which, listen carefully, the view in which the true shape of the base is visible, we need to draw that view first. So the true shape of the base is visible in the top view, not in the front view. Okay, because it is equally inclined. If it was not equally inclined, then we can start with front view also. Okay, but now the true shape of the base is visible in the top view. Okay, in the front view it would be slightly decreased length. So start with the top view. You need to draw a square of 40 mm side, and you already know that. Draw a reference line xy here. The light line is there, and on that point draw 45 degree angle in this direction, and let these lines go down in the 45 degree angle. Okay, and this is how the square has been prepared, and you already know, you have done in geometrical construction also, how to draw a square which is equally inclined to reference line xy. So name it A, B, C and D. So now we need to join the diagonal also. We need to join the diagonal also. Why? Because these are the slant edges which are visible as a shorter line in the top view. This is how the slant edges would be shown as in top view. Now from each point or each corner we need to take the projection. This is point number A. So the projection will intersect at this particular point on reference line xy, and from D also and from C also we would do the same stuff. Okay, now just above the A dash is here, right? And just above the B and D, B dash and D dash is there. And you already know that initially B is visible and D is hidden behind. That's why I have written B first and D dash in within the bracket. And here C dash is there. Now join this and make it as a dark line with the help of H pencil. And these outer edges are also kept as a dark with the help of H pencil. Now the axis height is 65 mm long. So we need to draw a line of 65 mm in vertical direction. Okay, so this point is known as O dash, and what is this height? This height is nothing but 65 mm. Actually it is the axis length. Axis is hidden just behind this O dash and B dash. It is not visible in the front view, but this is the height of the pyramid, or you can say axis length. Okay, now join O dash with A dash and with C dash also in such a way that, okay, initially you need to keep this line as a light line. Only this line and this line initially you need to keep as a dark. Okay, or you can take all the lines as light initially. Later on I will tell you which line you need to keep as a dark and which line you need to keep as a light line. Okay, now we are going to introduce our cutting plane. We are going to introduce our cutting plane. So this blue line would be parallel to xy. Okay, this blue line is parallel to xy, and on this particular point, okay, where my cursor is right over here, you need to put the protector here, protector center here, and draw an angle of 45 degree in the top direction, and let this line extend in the downward direction also in such a way that, so this height is how much? 32.5. Why 32.5? Because it is bisecting the axis now. So the cutting plane is passing through this center point 32.5. So at this center point you need to draw how much? 45 degree angle. So this is the cutting plane. This is the cutting plane which is used to bisect the solid in the two pieces. Okay, actually it is a, you can say, truncated pyramid, because pyramid has been cut at an angle now. So the when the solid is being cut at a angle to the base, then it is a truncated, otherwise it is a frustum. Okay, this thing we have discussed in the solid basic video. You can see that video also. So now the cutting plane has been introduced. So where the cutting plane has cut our solid, that is the main thing. That is the main thing. So let me show you where the cutting plane has cut our solid. He has cut here, here, and here. So 3 points are there. Actually these are not 3 points, these are 4 points. Because this slant edge is O dash, B dash is not single point, these are 2 points. Okay, so this is the 2 point. So now I'm going to name them. Now I'm going to name them. This one point is 1 dash, this point is 2 dash, and this point is 4 dash, and this point is 3 dash. So point 1, 2, 3, 4, how would they look like in top view? So I'm going to introduce our top view of this cutting point. Let me show you. Draw this line as a perpendicular, and this line will intersect at this point. Can you see that this point is the just top view of 1 dash? Okay, so this point would become 1. The top view of 1 dash is 1 na? Right. Similarly, initially I will do for 3 dash. So drop a perpendicular. Okay, so how to locate that this line would cut where? So O dash and C dash, between the O dash and C dash 3 dash point is right. So similarly, let me write this is our O. Okay, so between O and C, between O and C, 3 would be there. Similarly, as in front view, between O dash and C dash, 3 dash is there. Similarly, between O and C, 3 is there. And similarly for 1 also, between O dash and A dash, 1 dash is there, right? So similarly, between O and A, 1 would be there. And name it as 3. Now the thing is that the point 2 dash and 4 dash are on the same line. When I will drop the perpendicular, it will not intersect at any point on this OD and OB. So how would I do that? Okay, this thing we have done in development of solid surfaces also. So I am going to show you here also. So this line has been already extended. This line has blue line has already been extended, and it has cut on the true length. These are the true length. O dash and A dash and O dash and C dash are true length, because in the top view this line is straight, OC and OA. So the front view of OA and OC would be the true length. This thing we have discussed a lot. Okay, so now extend this line and this intersection point. Can you see that? Let me mark over here. This intersection point is here. Either this, sorry, either this or either this. Okay, you can take any of them. So drop a perpendicular in downward direction in such a way. From this point I have drawn perpendicular and it will intersect at here. So what you need to do? What you need to do, the intersection point is here. So you need to put the compass needle on the O and open as this much. Suppose this is our star point. This is our star point. So O star would be radius and you need to draw a arc in such a way that in this way. Okay. So again two intersection points would be there. First one would be this one and another one would be this one. So their names are which one? 4 and 2. In this way, we are going to obtain 4 and 2. Simply draw an horizontal line. It will intersect either here or here and draw a perpendicular in the downward direction. It will intersect OA at this certain point. This point is star. Open the radius O star and draw an arc, or you can say semicircle. Okay, it will intersect on OD at 4 and OB at 2. Now the things are pretty clear that how 2 and 4 points are being achieved. Now join them. Join them with a solid line. Join them with a solid line, and this is the view. This is how the pyramid will look like in the top view. I will finalize this, but initially I am interested in obtaining the true shape of the section. So the true shape of the section would be visible. How the true shape of the section would be visible? When I will go perpendicular to this cutting plane. When I will see from here, the true shape would be visible. Okay, to obtain the true shape of this cutting section. Okay, to obtain the true shape of this cutting section, we need to see from here. So what I need to do, from this point 1, from point 2 dash 4 dash and point 3 dash 4 dash, I need to draw, or you can say draw perpendiculars in such a way that, let me show you how the perpendiculars are being drawn. From 1 dash, this line has been drawn. This line is perpendicular to this cutting plane. Perpendicular to this cutting plane. Again from the point number 2 also. Okay, so later on I will do that. So open the compass how much. Let me show you how the radius you need to open. So from here to here, from xy line, how much distance is for point 1? So this one would be radius. This one would be radius. This red line would be the radius, and put the compass needle over here and cut it over here. Clear? So this one would be radius. We are taking the help of top view and drawing in the front view, right? Similarly, for point number 2 dash and 4 dash, what would we do? We would drop a perpendicular in this way. On this cutting plane, this line would be perpendicular. And how this length would be achieved? Let me show you. Let me show you. From this point, open the compass B4 and mark and radius here. Again, open the compass B dash and 2. Okay, now draw an arc in this way. Okay, similarly for 3. Similarly from 3, from this line, you need to open the compass of this much length. Okay, and from 3, I need to draw an arc in this way, and from here, the perpendicular would be there. So let me show you in the animation. Let me show you in the animation how the things will look like. Initially, this arc would be there. Okay, and the radius would be B dash and 4. This is how this point has been achieved. Again, take the radius B dash and 2 and draw an arc here. The center point would be this one. Clear? Now from point 3 dash, draw a perpendicular in this way. Okay, so open the radius of how much? Here my cursor is there. So this and this from up to 3. This would be radius where my cursor is moving. This one would be radius, and this 3 dash would be center point. For that much radius, you need to draw an arc in this way. Now these points are 1, 2, 3 and 4 in this way. Join them. 1, 2, 3, 4 point has been achieved. Now draw them in such a way that, okay, so this is how the true shape has been achieved. Now the only part is remaining as the sectioning line. How to do the sectioning line? Sectioning line would be at an angle of 45 degree. The space should be either 2 mm or 3 mm. Okay, so this is how the sectioning has been done. at an angle of 45 degree to the XY line. Okay, and similarly for the top view also. Similarly for the top view also, we need to do the sectioning, and the space between these two lines is either 2 mm or 3 mm, and they are inclined at 45 degree to this XY line. Clear? Now, some things we need to keep as a dark, and something we need to keep as a light. So how we do that? This thing has been kept as dark, and this one also, this one also, and this one also. Clear? Now in the front view also, the lower part is remaining with us and upper part has been extracted out. So we need to keep as a dark the lower portion. Okay, so this is how this problem has been drawn. I hope you get it. If you like the video, please share and subscribe my channel and share it to your friends also. Thank you very much.